some students wanted additional practice, so here it is. The reason we are balancing equations is conservation of mass. Matter cannot be created or destroyed. The mass of the reactants must equal the mass of the products. Therefore, the number of atoms on the product side must be the same as the number of atoms going into the reaction on the reactant side. Some tips: you only change the coefficients. You do not change the subscripts. The subscripts are the little numbers. Generally, you treat polyatomic ions as an indivisible unit, unless, of course, the reaction is what created the polyatomic ion in the first place, or decompose that polyatomic ion. You'll be able to see right off the bat if you can treat it as an undivisible unit or if you need to treat it as individual atoms. Next, think of balancing reactions as a spiral. You have to recheck every element after changing a coefficient. So if I had, let's say, carbon dioxide, and I changed that to be 3, any place that had carbon I'd have to change again, and any place that used oxygen I'd have to change again. Hydrogen is found in nature as hydrogen gas, H2. Oxygen in nature is also found as a diatomic gas, di meaning 2. Oxygen gas is composed of 2 atoms. We cannot change the subscripts. That's part of the formula. The formula is the ratio of the atoms as found in nature or the lab. Recall that atoms are doing what atoms do naturally, fulfilling the outer shell. A nice simple purpose in life. No fancy cribs, Porsche 911, or soccer cleats, just a full outer shell. Coefficients are the numbers placed in front of the compound to tell you how many there are. How many packages have I purchased? If it does not have a number, it's assumed to be 1. You would never write a 0. Instead, you would erase it entirely. So if it is there but doesn't have a number, you assume it's 1. So I have hydrogen, and it comes in packages of 2. And I have oxygen. It also comes in packages of 2. But over here, it doesn't come packaged like that. It comes in packages of 1. And I have Mickey Mouse. There's my hydrogens. That's the only way it comes packaged. So how do I balance this? There's a couple ways you can do it. I can say for my hydrogens, how many do I have on this side? How many do I have on this side? So right now I have 2. How many on this side? I also have 2. So that's balanced. 2 equals 2. Let's try oxygen. On this side, I have 2. See how that comes down there? So I have 2 oxygen atoms. How about on this side? Well, it doesn't have anything, so it's a 1. So I have a 1 on this side. Well, does 1 equal 2? No. So I need to have 2 here. Well, how did I get 2? I have to put a 2 in here. That gives me 2 oxygens. Okay, so that matches. Well, my hydrogen changed, didn't it? It comes in packages of 2. When I said I wanted 2, there's the other one. So I have 2 of these now. 1, 2, 3, 4. So now I actually have 4 hydrogens. You can just multiply it. I have 2, but they come 2 to a package. So now I have 4. Well, does 4 match 2? No, 4 does not match 2. So I have to change that. Well, I come over here. I need to have 4. But looking over here comes packages 2. So how many of those packages do I need? Well, to make 4 atoms, I need 1 more package. Here's 1 package. Here's 2 packages. So 2. 2 times 2 is 4. That's correct. 2 times 2 is 4. That's correct. So those are balanced. Now let's try oxygens. I have 1 package of 2 each. That's 2. I have 2 packages of 1 each. That's 2. So that's balanced. So now that's our balanced equation. I'll write it down here. So 2H2 plus O2 yields water. Yields 2 molecules of water. Okay, our next one, we're talking about reactants versus products. Again, we do the same thing. We form a column in the middle. Let's start with Al. Okay, how many reactants do we have? Well, so far we just have one. How many over here? Ooh, we have 2 atoms. Well, that's not equal to that, so we have to change this. We have to have 2 atoms on this side. Well, how do we get 2 atoms here? Well, it comes packages 1 and we need 2 of them, so that's that. So that matches. Okay, let's go on to our next one, oxygen. How many oxygens do we have over here? We have 2. How many do we have over here? Oh, we have 3. Does 3 match 2? No. So what do we have to do? Well, we've got to increase this somehow. Let's try the next one. Well, we can't get 4 because it comes packages 3. So if here was the Al, it comes here as 1 oxygen, another one. We can't split it. We can't say, oh, I only want half of that. We can only get another one, Al, and there's our 3 oxygens. Okay, so we had to put a 2 in front of here. 2 times 3 is 6. But we changed our Al, so 2 times 2, this is now 4. Okay, well, let's come over here to reactants. Does 2 equal to 6? No. We need to have 6. Well, where'd the oxygen come from? Okay, this one comes packaged as 2. Okay, there's 1 package, there's 2 packages, and now I have 3 packages. Well, how many atoms are? 1, 2, 3, 4, 5, 6. Or we could just multiply. 3 times 2 is 6, so none of that matches. Okay, well, remember how I said it was like a spiral? I come back around. Every time I change it, I have to come back and see. So oxygen is now okay, but let's check for the aluminum. So aluminum, here's 4. That's not the same as 2. So let's go ahead, and this needs to be 4 also. Well, you come over here, so that 2 didn't cut it. We need to have 4. And now, does it work? 4 equals 4, yep. 6 equals 6, yep. So we're looking good. So our balanced equation is 4Al plus 3 oxygen gas yields 2 compounds of 2Al O3. One way to think of these types is, how are you going to get it to balance? You need to recall your algebra and find the lowest common multiple of the 2 numbers, of the 2 and the 3, which would be 6. So let's go ahead and try this one. Again, you put it right there, nitrogen. Okay, on the reactants side, remember this is the reactants, and this is the products. What kind of reaction is this? Well, we had 2 products going into 1, so this is a synthesis. Okay. Well, let's get back to our balancing. So we have 2 over here, and we have 1 over here. Well, that's not good. 1 doesn't work. So we have to change that at least to 2. Okay, so now we have 2 on this side. Well, let's now go to hydrogen. How many on this side? We have 2 reactants. 2 times 3 is 6. 6 equal to 2? Heck no. So this comes packages 2. How many of those packages do we need? 1, 2, 3. See, 1, 2, 3, 4, 5, 6. Or 3 times 2 is 6. Now that's balanced. What kind of reaction is this? Well, what kind of reactions are there? There's synthesis, where you create something, decomposition, where you break it down, single replacement, and double replacement. We have 1 element here, and 2 there, and 2 there, and 1 there. What happened to form that? This replaced that, didn't it? And that gets cut out then? So this would be single replacement, because we saw something is being replaced. Why isn't it double? Well, this is only 1 element by itself. If that had something else to it, then it would be double, but it doesn't, so it's single. Now let's try balancing this equation. Well, let's start with copper. We have 1 copper on this side. Hey, that 3 goes with the O, that 2 goes with the nitrogen, doesn't go with the copper, so we have 1 over there. Okay. Let's try Ag. We have one over here. We have one over here. That looks good. Now, NO3 is kept NO3. So we can treat it as one thing. We don't need to break it down. Okay, we have it once over here, but how many times do we have it here? Well, we have it once here, but we have that twice. So that does not equal that. So this needs to go to 2. So we need to put a 2 in there, and it's like a spiral. You start it, and then you have to come back. Well, let's go back. Let's go back to the AG. Okay, AG is now 2. Well, 2 does not equal 1, so on the product side, I've got to change that to 2. Okay, so let's double check if this works. Okay, copper is still 1, still 1. Silver, you've got 2 there now, 2 silver, so that's the same, that works. Nitrate, we have 2 of them over here. We have 2 of them over here. So that is also, so this is now balanced. Further information, I would recommend going to Bosman Biology. He's done some nice stuff on balancing. If you didn't understand this, perhaps you'll understand that. Sometimes it's good to get different perspectives on doing these types of equations. Enjoy!